In this video, we're going to use RStudio to perform a k-nearest neighbors classification of a data set. Data set is the GEM data set, which again comes out of the JGIA textbook. And in the GEM data set, what we're trying to do is we're trying to predict which potential customers would end up getting a GEM membership. So with that, the k-nearest neighbors is really an excellent means of classification because it doesn't have any underlying distribution of target variables, anything that we need to do. Instead, what the model is trying to do is it's trying to look at in this case, customers that are similar to other customers and say, group them in little buckets of neighbors and say, if based on this group of neighbors, do these people buy a GEM membership or do they not buy a GEM membership? So what the k-nearest neighbors does is it goes through several iterations and says, what's my best model? Should I look at the 2 closest neighbors, the 3 closest neighbors, etc.? And it finds a way to, using the data and the number of neighbors, find something that does a good job of classifying or predicting whether or not someone is going to buy a membership. The example that's being used today is example, let me make sure I tell you the right one, 12.1 out of the JGIA textbook. And you're going to have to scroll through a couple of pages because we're going to be using R today to make this happen. I think you have already seen this in the past, but just in case, first thing we need to do inside of RStudio is to import our data. And you can do that by going to File, Import Data Set from an Excel file. And when you get in, you can look for the data you're looking that we want to use. In this case, you need to have already downloaded the GEM data. Okay. And when you get ready to move forward, come to the box down here in the bottom and rename this My Data. All right, and the reason for doing that is that's the way the textbook does it. I've already loaded the data, so I'm going to click Cancel. You would click Import instead. When you've done that, you should get a line that basically comes through and says, okay, we've just gone through. We've imported your data. At this point, you should be on step B or Bravo of the example. And the first thing that happens is trying to install the packages. R comes as a shell, and then there are programmed packages that are needed for doing separate techniques, analytical techniques. So the first one that it tells you to do is install.packages and the whole line here. If you make a mistake, it will throw an error and you can just take and copy your line again and restart again. But you type in the command and you hit enter. Whenever you do this, if it's the first time that you've done R, it may go through and install a lot of different programs, okay? And it's trying to install it to where it can get back to RStudio and bring these things. So it may run for a while, don't panic, just let it run through. And then finally at the end of it, it will get you back to a little command prompt. And the command prompt is just this little greater than sign. All right, at that point, you're going to go ahead and load the library caret, hit enter. It may give you a little bit of information here. You're going to load the library of gains, type this in, hit enter, library PROC. In this case, it again gives you some information. It says that you need a citation that's attached with it. It's going to go in, do a little bit of work, and then finally it will come back to a command prompt. Here we're going to, in this first line that we're actually going in to rescale the data, we're making the previous my data, we're making it into a new data set. All right, and you can track the data over here on this right side of the environment. You can see my data comes in as 1,000 observations with 4 variables. And now we're going to create something called my data 1. And in my data 1, say, let's take the data frame of, with my data 1, we're taking and we're going to scale my data, and we're going to scale columns 2 through 4. And 2 through 4 with this data was age, income, and hours. All right, so it's going to scale that. And that scaling really is, that is the standardizing the values in there. The next thing that we're going to do is we're going to come in and again, I know when you're doing this, if you've never done this before, it seems just like you're typing and hitting enter and just waiting for an error code to come up. Until you get more used to using R, what you're going to end up doing is just that same thing. You're just going to be basically typing and trying to move forward and trying to overcome anytime you get an error. So with that said, just keep trusting it, keep moving forward with what's going on. However, at the same time, try to understand a little bit of what's happening as you go along here. Again, in this one, we standardize the data. You hit enter. It comes to a command prompt. You're ready to go again with the very next line. The next line is taking and it's appending. This is saying take my data 1 that you just standardized, and we're going to append on the end of it the enrollment. All right. Then you'll hit enter. The next line, you're going to actually rename the 4th column as enrollment. All right. Again, be very careful as you go through here that you're using single quotes whenever single quotes are called for, double quotes when they are called for. Finally, this last step of this section here, what we're doing is we're taking and we're converting the enrollment field, and we're changing it to a categorical data. Again, it seems very odd when you're doing it. When you're using R a lot, you will take these scripts and you'll have them saved in libraries, and it's just not. I mean, it's gonna feel fine whenever you've been using it often. All right. Next thing that we're going to do, we're going to get ready to partition this data set. And in partitioning it, we're going to take 60% of it and we're going to use 60% to actually train the data. And then the other 40% we're going to go back and we're going to validate. So first step is to set a seed. This is a random seed, a random number generator, because a random number is going to be assigned to each and every one of the data fields, so that the partition is based on the random number that's given to it. So we set a seed of 1. You could put another number in there if you want to. However, the seed gets set here. And we're going to go in and we're going to create a new set called my index. And my index is a partition of your my data 1 enroll data, and we want 60% of it. All right. Similarly, we're going to make a training set. The training set is my data 1, my index. And you see on this, I got an error. And the reason that I got this error was that my data 1, this is misspelled. All right, it's case sensitive. It should be a lowercase m. So whenever you get these errors, copy what you had, paste it back in, make minor changes, and keep moving forward. All right, so that gets the training set. Validation set is the my data, and it's everything that's not in my index. All right, so the 60% went up there, 40% goes down here. So that's what's going on in this section. The next section that's going on is we're trying to get a control set up for a cross-validation of 10 components. That's what this line does. Again, type in the line. When you get to this end part, hit enter. At that point, we are, this next line, what's happening in the next line is we're trying to say, we don't want the computer to go through and just, find up to, 199. That's not true. 999 neighbors it could go up to find an answer. Instead, in this line, we're saying, hey, let's limit this to no more than 10 neighbors. So that's what this line is telling us. My grid, limit us to 10, hit enter. Again, we're going back in for another command that we're about to set for it. So we set a seed, a random seed again. And in this seed here, what we're doing is we're trying to get ready to create our trained data set. And in the trained data set, we're going to call this KNN, or the K nearest neighbors fit. We're going to train our data. When you get to this little tilde, you probably don't use this often. On my keyboard, it's actually located above the tab. It's going to take you a while to find it, possibly. And then once you've written that in there, make sure again that you're getting the periods, the commas, all in the correct lines. You'll notice that in your book that the lines oftentimes wrap around. That's not telling you to hit enter and come back again. Instead, just go ahead and continue typing that line until you get to the very end of it, and then hit enter. Once you've done this, now we're ready to look at our fit. So type in the KNN fit, and it says, here's what we've done. With our 600 samples that were in there, I know we told it to do 60% based on the random numbers. It actually put 600 in this set. And from it, we get an accuracy, and the accuracy is for the 10 different models that it ran. Whenever K is 1, the accuracy was 88%. When K was 2, which means that it took the 2 closest members to it, it goes up a little bit more. And then in this case, whenever we got to 6, this was the highest. The optimal value was at K equals 6, where we were predicting at the 91.3% level. All right. The book, I think, actually went to 9. You may be somewhere a little bit different than that based on the random seed and the numbers that were generated. So it's going to get you close. It's not going to be very different. And what we're trying to do is, just find a model that's going to fit better than the a baseline model. All right. At this point, we are now ready to be moving on to step H, as in hotel. And in step H, we want to display our confusion matrix. So there is we make a new data set called class, where we bring the information in. And once we bring that information in between the predicted and the actual values again, this is for our holdout data, our validation set, we create a confusion matrix where positive is 1. And the confusion matrix comes up and says, you know what, when we predicted a purchase, then we ended up with 146 of those where we actually got a purchase. The accuracy of this was 0.9048. The sensitivity is 0.9068. And you remember the sensitivity is the portion of the target class, in this case, that they enrolled actually happened. All right. The side to that is the specificity, and that's the proportion of the non-target class, which is the people didn't get a membership, that were classified accurately. All right. So again, you can see that, that we're in that 90% range of being able to classify overall, almost 91% for saying, purchasing really did happen with purchasing. 90% said that we predicted that they wouldn't purchase, and they didn't. So this is really this is a pretty good set. This is a pretty good model for us. All right, now we're going to move on from here, and the next set that we get to is I. And in I, again, we're going to move forward with another set of commands. Enter, type in the class and prob afterwards. And here we are once again, predicting whether or not something happened based on our data, right? This is the probabilities that the item actually is going to occur. And remember the purpose of those probabilities. When we were working with these probabilities before, we said that we could take a probability and create a model based on setting a threshold, right? So if we set a threshold in here based off of calculating the probability that someone was going to buy, then we could create our own model and move away from what the canned model was telling us. In particular, in RStudio for k nearest neighbors, the probability that it wants to stick with is 0.5. Now you can take and change that, and with the book, the decision was made to go ahead and go with 0.403 as the cutoff, based on the detection prevalence that we got from our sensitivity, from the confusion matrix. So 0.403 was chosen as a means now to do a cutoff based on this probability. So we created the first model and ran it and said, hey, this is the results that we got. Now we're going back in, we're going to run this again with k nearest neighbors, but this time we're going to set the cutoff at 0.403. Again, that's not just a magic number, it came from the detection prevalence from our confusion matrix. So now we type in, and you'll see here that 0.403 is the argument that we put in. And from there, when we hit enter, we have a new confusion matrix that's created based on a 0.403 instead of a 0.5, accuracy of 0.9173, which is slightly above what we had before. And then on the sensitivity has certainly gone up here. So my model, your model may be a slightly different based on the items that were selected to come in. My model, this plan of going with a 0.403 actually gives me a better classification model on the data sets. All right. Next thing that we're going to go through is we're going to use the confusion matrix again and make a gains table. And in the gains table, we're setting ourselves up for doing another model. All right, gains table comes in. This is breaking things into the different categories. It gives us our lift. We're starting to see from this lift that when we get to the four components, that we get 94% of all of our data is in there. And then the last thing that we want to accomplish is to make a cumulative lift chart. Now there's a lot of steps that go into this, and you're going to, at some point with all of this, you're likely to make a mistake again. When we start the process of making this graph, all of this line starts going in. It's telling the computer is telling RStudio where the data is coming from. It's telling how the data needs to be set up. It tells you the labels for the x-axis and for the y-axis. And then in mine, I actually made a mistake first time, and I put a type equals 1, and it's really not a type equals 1. Instead, the type equals L, all right? And then so I punched that in, and whenever we finish, I'm able to go ahead and put the very last line on here, which is the getting us to go ahead and build the plot itself. At this point, you should have a graph that says cumulative chart. Last things I'll go with, I know that, as I mentioned, getting used to RStudio was difficult. However, being able to walk through this, being able to create a graph, being able to see all of the different data fields that you're making, manipulating the data, and then interpreting the results that are coming out. Those are the skills that I want you to be able to start working through so that you can use RStudio to do these things in the future. All right? Good luck.